before you start lesson 40, make sure you complete test G on fraction operations. Lesson 40, we'll be looking at a couple of ideas on angles, and one of them is the sum of the angle measures of a triangle, and the other one we'll be talking about relationships between angle pairs. Now remember when we learned about the area of a triangle, that was equal to the base times height divided by 2, and we learned about that because we took a rectangle and we split it in half, and that told us that we had two triangles there, and so the area of one of those triangles would be half the area of a rectangle. Now rectangles have square corners or right angles at their corners. And what that means then is the measure of any angle for a rectangle, any corner, it's going to all be 90 degrees. And let's just think about something here. Think about the angles that we've made here with our triangle. That's about a 50-degree angle right there. So that means the angle on the other side would have to equal 40 degrees, right? Because they have to total up to 90. Both of those angles together would equal that corner on the left side of 90 degrees. Likewise, up here at the top, this angle would be 50, and then the other one would be 40. Now, add up all the angles in each of those triangles that you have there. The top one you have a 90, a 40, and a 50. The bottom one you have a 50, a 90, and a 40. Both of them total to 180 degrees. That's how all triangles are. The sum of all the angles in any triangle equals 180 degrees. Always. Doesn't matter its shape, whether it looks like this, like this, like this. The sum of the angles, all three angles in any triangle, will add up to 180 degrees. To help you understand that concept more, you might want to do the activity that they have on page 272 and 273. Now let's look at some angle pair relationships. For example, these two angles, we said those added up to 90 degrees. And anytime you have that, where you have a right angle and then it's split into two different angles, those are called complementary angles. Remember that. Complementary angles add up to 90 degrees. Now let's talk about a few other angle pairs. And look at this diagram that I'm going to draw here. We'll call this angle 1, this one angle 2, that one angle 3, and this one angle 4. Those are basically like two intersecting line segments. And there's a couple of things here. Let me draw a blue angle measure from here all the way over there. That's like a half a circle, right? That I just drew, a semicircle or half a circle. That would equal 180 degrees. Just think of two right angles back to back. That would total up to 180 degrees. Those are called supplementary angles. So angle 1 and 2 are supplementary angles. Supplementary angles always add up to 180 degrees. Now there are 4 angle pairs there that are supplementary angles. 1 and 2, 2 and 3, 3 and 4, and then 4 and 1. All those 4 angle pairs, if you look at them, you can see that they would add up to 180 degrees, which is a straight angle. Now another relationship is opposite angles, or they're called vertical angles. I don't know why they call them vertical angles, where that came from, because they're not like straight up and down from each other. They're really opposite each other. Vertical angles are always equal. Try to remember that. That's something good to memorize. When you hear the word vertical angles, that means opposite angles. Those are equal to each other. So in our example that we have here, angle 2 equals angle 4, and also angle 1 equals angle 3, because those are opposite or vertical angles. Let's talk about one more thing here, adjacent angles. Adjacent angles share a common side. So we basically talked about two types of adjacent angles. We talked about complementary angles. Look at my little blue complementary angle drawing. See where I just drew that red tick mark? Those two angles have that side with the red tick mark in common. So those are called adjacent angles as well. And then the other kind of adjacent angle is that we've discussed here are supplementary angles. They have one side in common. Let's go ahead and do some practice problems. Look at practice problem A. The angles in a regular triangle are all equal. Each one measures blank degrees. And maybe remember in lesson 18 we talked about regular polygons. They have all the sides and all the angles equal. And there's also descriptions of regular polygons on the very last page in your book. We said already that the sum of the angles in a triangle adds up to 180 degrees. So if all those angles are equal in a regular triangle, they'd have to all equal 60 degrees, right? Since 60 times 3 of them would equal 180, each one measures 60 degrees. So that might be something good to remember. In a regular triangle, the angles all are the same. They all equal 60 degrees. Look at practice problem B. I want you to tell me what the measure of angle B is. Well, you see the right angle box on the corner there, so that tells you that those are complementary angles. That means they have to add up to 90 degrees. If one of them is 30, that means B has to equal 60 degrees. Let's do one more problem. I want you to figure out what angle X, angle Y, and angle Z equal. And let's just think about this first. We have a 30 and 110 degree angle inside that triangle. We know that the sum of the angles in a triangle has to add up to 180. So that means that 30 and 110, which would be 140, plus X has to equal 180. So that means X must be 40. Now, X and Z are vertical or opposite angles. So that means Z has to be 40 as well. And then X and Y are supplementary angles. Y and Z are also supplementary. So either way, Y must be 140. I can put degree symbols on all of those. Since supplementary angles add up to 180 degrees, right? X plus Y, 40 plus 140 would be 180. And that's our answer. So those are some good angle relationships to remember. You'll be working with angles a lot in the next few years. So if you remember those basic relationships like that, that'll make a lot of your problems that much easier. Okay, well that's all for lesson 40.